Hey everybody, welcome to another Con support video. This one is on scale copies. So let's get to work. I'm going to copy and paste this over here to my workboard so that I can show you guys stuff and write on it. Make it a little easier for us to play with. Alright, so first things first, it says a figure A is a scale image of figure B. Alright, so they're telling you that they're scale images, which means that they're similar figures. So whenever two figures are scaled versions of each other, they're a similar figure, which means that there is some relationship y equals kx that models the relationship between the two figures, and where k is your scale factor, x is your input value, and y is your output value. Okay? So it says figure A is a scale image of figure B. We know that. It says what is the value of x? So I'm going to show you guys kind of a little bit extra information just to make sure everyone's really comfortable with all the ideas, right? So if you were to look at corresponding parts here, 6 corresponds to 9. You have to find two parts that correspond to one another on the scale figures. Once you have that, they're the key to unlocking the equation going both ways. So if you're starting with figure A and you're going to figure B, right? What is the equation that you'd use? Well, now the input is going to be 6. The output is going to be 9. So it's something times 6 that equals 9, right? That's going to be your scale factor. So the easy way to solve for k is literally to algebraically solve for k. And you can see that if you divide both sides by x, you isolate k. Therefore, what is k always going to be equal to, as you guys hopefully know by now? It is the ratio of output over input. So it is y over x. Let me make that a little less blurry looking. All right, so all you got to do is decide what your input value is, what your output value is. Look at the two corresponding parts. Output over input is your scale factor, your multiplier. So if we're going from A to B, all right, then we're going to just say the output is 9, the input is 6. So our scale factor going from A to B is going to be y equals 9/6 x. Now, 9/6 can be simplified, obviously, to 1 3/6 or 1.5. So you can think of that as y equals 9/6 x. You can think of that as y equals 1.5 x. You can think of that as y equals 1.5 x. These are all the same things, okay? And basically what it means is that the large figure, figure B, is 150% the small figure. So it's the 100% of the small figure plus an additional 50%. It's 150% the size of the small figure. That's what it means. If you're going the other way, going from figure B to figure A, all that changes is your input and output, right? So now you're inputting figure B's values and you're outputting figure A. So going the other way, the ratio would not be 9 over 6, but it would be 6 over 9. So if you went the other way, you'd have y equals 6/9 x, or y equals 2/3 x, or y equals 0.6 repeating x, okay? That means that basically figure A is 66.6 repeating percent of figure B. This is the relationship going both ways, okay? Once you understand that, you can use either equation to solve depending on what you're starting with. In the case of the x value, the corresponding side to the x is the 12. We know that we have this figure A value, but we don't have the figure B value, which means that we want to go from input A to output B. And we know that we're going to plug in the 12 for figure A, for the input. So you're going to use this one over here, which is the 1.5x, right? We're going to take the 12 and replace the x with the 12. This is our inputting figure A's value. We're going to output figure B's value. So the variable x kind of confuses everything, right? Because x is input, but then x is also this missing side length. I hate when they do that. But let's just, this x that they're having right here is going to be the output. And it's equal to 1.5 times the input, which is 12, right? The way that they use the x here just makes it confusing, but ultimately it doesn't matter. You can call this question mark. It can be any letter you want. It's just what is this mystery value, right? And it's the output value when the input is 12. And you have a scale factor of 1.5 going from input to output. So anyways, long story short, what is 1.5 times 12? 1 times 12 is 12. Half of 12 is 6. So you're looking at 12 plus 6 or 18. So the value here for 8x is going to be 18. So that's what you would put as your answer, okay? So what is the value of x? You would say 18. It's that easy. Now, if you don't want to do all the rigmarole of writing the equations out here, and they give you an option to use a calculator, here's a really easy way to do it. You just go output divided by input, and then times the input value that you want to find the corresponding output for. So watch how you can punch into a calculator really easily. You just do 9 divided by 6, get your multiplier, and that's your scale factor. Input times 1.5 equals output. So input's 12. 12 times 1.5 is your answer. 18. Okay, so you can just do this idea of how to set up your y equals kx ratios and scale factor and equation. All right, let's go to the next problem. So we got that one right. Next one. Okay, so let's erase all this work that we got here. Let's get rid of this stuff. Bye-bye. All right, now let's get rid of this diagram. And let's see, this time we've got Control-Shift-F. Let's copy this one here. We're gonna do this over here. Boop. Now, because they keep doing this thing where they make the x the unknown, which I really don't like, because they know that you're going to be using y equals kx. So why are they using x for an unknown that's not going to be necessarily your input value? I don't know. But ultimately, what I would do if that's the case is you can just think of A and B, right? Capital A and capital B as your input output, and we can go from there. So let me show you how that might look. All right, so if we take a look at this equation here, this relationship, these two scale drawings, this time it tells us the scale factor. That's kind of cool. So it says figure A is a scale image of figure B. Okay, so we know these two are similar figures, which means all of the angles are the same and the size are proportional. It says figure A maps to figure B with a scale factor of 4/9. So figure A maps to figure B. Now the way they wrote that is a little bit weird, isn't it? But we understand that if the scale factor is 4/9, that is a reduction, right? So that means that figure A is being reduced in size by a scale factor of 4/9 to figure B. Okay, so that's what it means. So ultimately what you're talking about here is the input being figure A and the output being figure B. So what do we know? We know that the equation going from A to B would be that figure A is the input, figure B is the output. So B is equal to the scale factor 4/9 times figure A. That's what they're telling us. That B is equal to 4/9 of A, right? The figure A maps to figure B with a scale factor of 4/9. We know there's a 4/9 scale factor. Obviously, the larger one has to be multiplied by something that's less than 1 as a scale factor to get the smaller one, right? Because we're reducing in size. So we know that this 4/9 multiplier goes from A to B, not the other way around. So now we know B is equal to 4/9 of A. Great. What we want to find is X, right? Now, if I want to find X, I know that if I go from A to B, I'm going to get this equation right here. B is equal to 4/9 of A. But what if I want to go the other way? Because what I really want to do is I want to go from this known 16 to the unknown of X, right? Well, then I should know that if I start with figure B as my input, then figure A is my output. And in the scale factor, instead of being output over input being 4/9, the output over input is going to be the reciprocal of that. So you just flip the reciprocal, and now it's 9/4. And then you have it set up correctly. So if B is equal to 4/9 of A, then it must also be true that A is equal to 9/4 of B going the other way, because you're just switching your output and input, right? So you switch the output and input, and you switch the scale factor to its reciprocal. So that's kind of the thing we're going to use here to solve. So we know that A must be equal to 16 times 9/4. So 9/4 times 16. And then we just get the answer for the corresponding part on A. So let's do that. Cancel the 4 and the 16, 1 and 4. And then 9 times 4 is 36, okay? So that means A must be 36, okay? Now just to test it out to make sure that we didn't make any boo-boos, we know that from A to B, it's going to go with a scale factor of 4/9. So if you were just to mess with this on a calculator and make sure that you have the right idea, then it must be true that if this X value is 36, that 36 times 4/9 is 16. Let's see if it is. Is 36 times 4 divided by 9 equal to 16? Yes, it is. So we know that we did it right. So we know the two equations. We know going both ways what the equations would look like. And we know the unknown value x is actually equal to 36. All right, next up. Let's erase this stuff. Bye-bye all this. All right. Right, let me get rid of this. And of course, get rid of this. Okay. So this one says, zoom in, grab this, paste it over here, move it around. All right, cool. So this one says figure A is a scale image of figure B. Okay, what is the value of x? So once again, we're looking for this unknown value. This time they don't give us a scale factor, so we've got to identify corresponding parts ourselves. So I'm not sure why that went dark. All right, cool. So we know that looking at the two figures, it's pretty clear these two trapezoids, right? The smaller base corresponds to the smaller base. So we can see that 20 corresponds to 24. Remember, the bases are the parallel sides. So in any trapezoid, right, the two parallel sides make the bases, and then you have a smaller base and a larger base in this case. The two smaller bases correspond to one another. So figure A's value is 20 when figure B's value that corresponds to it is 24. Okay, we want to go from figure A to figure B because we know the unknown is on figure B. So we're going to go this way, all right, which means that we're going to start with A as our input. We're going to do B as our output, okay? So in our equation that would normally be y equals kx, what we're going to have is we're going to have B equals some scale factor times A, right? That's basically what's going to happen in our case so that we don't get confused with our variables, since x is this unknown side of figure B. So what that's telling us is that we have to look for the relationship between figure B and figure A, where B is the output and A is the input to find our scale factor. So our scale factor is going to be B is equal to 24 over 20. So the scale factor is 24 over 20, and then you multiply A by that to get your value of B, right? Input A times it by output over input, and you get the output. So 24 over 20 is the same as 1 in 4 20s, which is the same as 1 in 1/5. So really what we're talking about here is B is equal to 1.2 or 1 in 1/5 A. That's what it means. Which means that if you think conceptually about what this means in context, it means that figure B is 120% the size of figure A. It's 100% of the length of figure A, and then you add an additional 20% of figure A. That's what it means. Okay? So that's the multiplier, that's your scale factor between the two figures. All right? So if I'm looking for x, I know that x corresponds to 60 because I can see that that is the corresponding element, right? It's pretty obvious. So now I'm going to say that the input value of 60 times 1.2 will be equal to the output value of x. So x is equal to 1.2 times 60. Well, what's 100% of 60? 60. What's 20% of 60? 12. What's 60 plus 12? 72. So we know that x must be 72. And that's the answer. So that's how you do the problem. Okay? Let's do the next one. By the way, on this last problem, right, obviously if you were flipping the input output and went the other way from B to A, your multiplier wouldn't be 1.2. It would be basically looking at this relationship. Instead of being 6/5, it would be 5/6, right, if you went the other way. Right? Which hopefully you guys are getting comfortable with that reciprocal scale factor going the other way because you're changing your outputs and your inputs. All right, back to the next problem now that I've done talking about the last one. All right, let's delete that. Boop. All right, Control Shift S for me. Let me grab this next thing. All right, I pasted it in here for you guys so you can see as I mark it up. All right, cool. Okay, it says a figure A is a scale image of figure B. So once again, angles are the same, sides proportional. It says figure A maps to figure B with a scale factor of 1.75. Well, obviously figure B is larger than figure A. So what it's saying basically is figure A times 1.75 equals figure B. That's what they're saying. So that means your equation that you're given here is that when A is the input, you multiply by 1.75 to get the output B. So B is equal to 1.75 times whatever A is. Okay? So that's the equation we know. Now, the nice thing is the X value is following this equation perfectly. So you're going to input the A value, you're going to output the B value. Perfect. So you're going to get X value, which is the value of that side length on triangle on figure B. Let me make that look a little less wonky. There we go. Is going to be equal to 1.75 times the corresponding A value, which was 3. So we can see that these two sides correspond to one another, right? The smaller bases correspond to one another in the trapezoid. So now that we know that these two are the bases, right? And the smaller bases are the ones that correspond to one another, we can then just say that 1.75 times the corresponding part on figure A is going to be equal to the corresponding part on figure B. So what is that? X is equal to 1 times 3, which is 3, right? And 0.75 times 3, which is 1.5 plus 0.75, so that's 2.25. So what you're really looking at here is 3 plus 2.25, which is going to be 5.25, right? And so that's just like 100% of 3 plus the 75% of 3, because figure B is 175% of figure A. And so we're looking at 5.25 as your answer for X. And that's it. So just go 5.25. Now remember, if you were going the other way, right? So if I know that this is the relationship, right, going this way, and I'm telling you that B is equal to 1.75A, right? Then if I were to ask you, just in theory, like if I were to ask you what is the relationship going the other way, you're just going to switch your output and inputs. Now it's A is equal to something times B, right? Basically, right? Because B is your input and A is your output. Well, what's 1.75? That's the same as 1 3/4. That's the same as 7/4. So if I know that the multiplier going this way, B is equal to 7/4 A, then if I flip that top to bottom, I'm going to get the multiplier going the other way. So you would say that A is 4/7 of B, right? And that makes sense, right? So if we plug that in, think about the idea here, 5.25 times 4/7 should equal 3. Let's see if it does. So just as a fun little experiment, right? Watch this. 5.25, the value we got for x, times 4/7 should equal 3. So times 4 and divided by 7. Bada bing, bada boom. Isn't that cool? So you once you know the relationship going one way, you can easily find the relationship going the other way, right? It's just the reciprocal relationship. All right, cool. Anyways, I think it's cool. Let's stop there. We're good.